Hello my dear students, I welcome you back to this channel, the classroom. Once again, before we start with the topic, today's topic is ionic compounds. So just think of the topic and listen to this good soft music, okay? Let it speak to your heart and let it bring calm to your mind. It's bringing calm to my mind. So good music. Music is so powerful. Do let me know in the comments how many of you love to listen music, and do suggest some good music to me, okay? Because I love to listen music. I just got this song from an Instagram reel, okay? I think there's a festival called Shiroi Festival, which is going on or which got ended. So I think it's held in Imphal, Manipur. So I got this from one of the users who uploaded this in a reel. So catchy, so good. I just downloaded it and I'm listening to it like crazy. Oh, bro, the good part. We have to move our bodies now whenever we're listening to good music. So I like to move my body. I don't know good moves, but then it's a loss if I don't move my body. So this is the move, my favorite move. Oh, the song did not end. Good. The name of the song is Nawaila, sung by HT Paiso. Okay, Nawaila, sung by HT Paiso. Search for that. So good. I like this song. Okay, class, thank you. So that's it. That's the way we build the energy in this classroom before we start the class, okay? So in a way, this refreshes your mind, okay? And for me though, it refreshes me a lot, okay? So this is how I like doing things, okay? So I hope you're all ready now. So today's class, the topic will be ionic compounds, okay? This is a very important topic. So let's go into the class. But before that, let me welcome you all. So my dear students, I welcome you all to this channel, Classroom. My name is Benatang Paton, and together we learn here. So now let's start directly. Let's go into the topic. So a very important topic called ionic compound, and plus very easy, okay, students? So I'm sure, okay, you will understand this. Okay, it's a very simple topic. So let's first define what ionic compounds are. So let's write the definition of ionic compounds. So what are ionic compounds? So what are ionic compounds? I hope you're holding your books, pen or pencil, because that's the number one rule in this classroom, okay? I want my students to write, not just listen, because you retain it better if you write. If you just listen, no, there is no retention power. You write. When you write, the coordination between your eyes, brain and hands, they work better, okay? So please write. So what are ionic compounds? So compounds form by transfer of electrons. Transfer of electrons are called, the ink is low, let me change this. Compounds formed by transfer of electrons are called ionic compounds. So this is the definition of ionic compounds. Compounds formed by transfer. Okay, transfer of, what are we transferring? Transfer of electrons. Remember class? Okay, transfer of electrons. So compounds formed by transfer of electrons are called ionic compounds. Now see, we have got metals and we have got non-metals. Okay, let me build the concept for you so that once the concept is built, you will understand better. So this part is the concept part. Okay, it is very important and crucial that we understand the concept, because if you don't understand the concept, you don't learn anything. Okay, so concept is very important. So let's build the concept first. So remember class that metals lose electrons. It's the spelling of my electron spelling, correct? ELEC. Metals lose electrons. Okay, and non-metals gain electrons. Non-metals gain electrons. ELECTRONS, electrons. Remember this. So all metals gain electrons and all non-metals receive electron. So metals, okay, they lose electron, so they are giving electron, and non-metal, I am a non-metal, I gain electron, I receive electron, right? So remember this, metals lose electron, metals gain electron. Don't worry, we'll use an example also. So for example, see, let's take an example of sodium chloride. Okay, NaCl. Now NaCl is a ionic compound. I'm taking an example of an ionic compound because our topic is ionic compound. Okay, I will be explaining to you in detail what ionic compounds are. So the metal here is sodium and this is the non-metal. So this is the metal and this is the non-metal. Okay, this is an ionic compound, and since this is an ionic compound, this compound is formed by transfer of electrons. So transfer of electrons, okay, has taken place, okay, which has resulted in the formation of this compound, which is sodium chloride. So let's try to understand. Okay, I will teach you how transfer of electron took place. So the first thing that you have to understand here is this very point number one. Okay, point number one, you have to understand this one. You have to understand this point number one, which is metals lose electrons. So the metal here is sodium. Sodium loses electron. Sodium will lose electron. All right, still not clear? Now see, I'll explain to you. So sodium, so metal part, let's write here sodium. So sodium, what is the atomic number of sodium? Atomic number of sodium, anyone? Atomic number of sodium is how much? 11. So sodium is atomic number 11. Okay, remember, atomic number of sodium is 11. So 11. So arrange the, now give me the electronic configuration of sodium. So 11, how will you arrange? 11 will be arranged like this. 2, 8, 1. Yes or no? Okay, or we can also write like this. Okay, yes. See, atomic number 11. Yes or no? Now what about chlorine? Chlorine, atomic number of chlorine. Chlorine atomic number, how much? Chlorine atomic number is 17. So atomic number 17. Okay, let's write somewhere here 17. Okay, and let me write here 11 also. Okay, so 17, give me the EC of chlorine, which means the electronic configuration of chlorine, which will be 2, 8, 7. 17 or not? 8 plus 2, 10. 10 plus 7, 17. Check here. 8 plus 2, 10. And 10 plus 1, 11. Okay. So this is called the EC, electronic configuration of electronic configuration. These are called electronic configuration. Okay. Here, this is the electron in the first shell, and this is the electron in the second shell, and this is the electron in the third shell. Now, very important point here, okay, which you should know is that, see here, this is the third shell. So third shell, the number of electron in the third shell, this is the first shell, this is the second shell, and this is the third shell. The number of electron in the third shell is 1 here. Okay, that makes sodium unstable. In order to be stable here, in order to be stable in the third shell, the number of electron should be 8. Okay, so to be stable here, the number of electrons should be 8, but sodium has only 1 electron. So that makes sodium unstable. Now let's go and look here. Okay, now here this is the first shell. First shell has 2. Okay, 2 is stable. 2 is stable for the first shell only. Okay, so 2 is stable. Remember, even for sodium, 2 is stable for the first shell. Remember, 2 is a stable number for the first shell. Okay, so for the first shell, stable number is 2. Okay, remember. So first shell, stable number is 2. Second shell, stable number is 8. And if you ask me for the third shell, actually it's 18. Okay, but then for the first 20 elements, okay, from hydrogen to calcium, this is chlorine. So chlorine, argon, chlorine, potassium, calcium. For till calcium, which is 20, they will settle for 8 in the third shell also. So we can also write 8, because for the first 20 elements they settle for 8. So the third shell here, so the second shell, this is the second shell stable number is 8. So first shell stable, second shell stable. We are discussing for chlorine. Okay, and then this is the third shell number is 7. Okay, chlorine will settle for 8, but then it's not 8, isn't it? Right now it's 7. So chlorine is also unstable. So chlorine also unstable. This chlorine is unstable. What about our metal here? Is metal also unstable? Yes or no? Unstable. Why am I saying unstable? I am saying unstable by taking the number of electrons in the outermost shell. I repeat. Okay, I repeat. I am saying unstable. I am declaring that sodium is unstable by checking the number of electrons in the outermost shell. Okay, the number of electrons in the outermost shell is 1. So carrying 1 electron in the outermost shell, sodium is unstable. Let's go here. Forget about the first shell, forget about the second shell. Check the number of electrons in the outermost shell. Okay, in the outermost shell, that means the last shell. This is called the innermost shell. This is the middle shell, and this is the outermost shell in this atom. So look here. Don't look here. Don't look here. Focus on the outermost shell. Okay, 7. 7 is not 8. 7 is not 8. For the third shell, okay, it has to be 8. Okay, since chlorine is 17 only, it's below 20 only, so chlorine will settle for 8. But this is 7, so chlorine also unstable. I hope it is clear. Okay, so unstable. Okay, so let me just use this. Let me just say that they are born unstable. Okay, just for example. Okay, unstably born. Now it so happens that they don't like this. Okay, they don't like this, nor does this like it. They don't like it. Sodium doesn't want to be unstable. Okay, just like human beings, we all want to be stable. I want to be stable. You want to be stable. Okay, you want to be stable in life. Everybody wants to be stable in life. Okay, we should be stable in life. So in the same way, atoms, elements are also just like us. They also want to be stable. So they don't want this title of instability. They don't want this title of instability. They want to be stable. So what he will do, he will not just remain quietly. Okay, he will not just accept that, but he will restructure himself. So what he will do is, he will lose this electron. He will let go of this electron. Okay, he will lose this electron. So sodium will lose this electron. Isko chhodega. So it will lose this electron. Lose this electron. Sodium is a metal or non-metal class? Sodium is a metal. Okay, and it is losing electron. Metals lose electrons. Yes or no? Understood? Metals lose electron. Let's go here now. Now chlorine. What will he do? Now see here. Okay, just read this sentence. Metals gain electron. So if I ask you, will chlorine lose electron? The answer should be, is chlorine a metal or non-metal? Non-metal. Do non-metal lose electron? No. Non-metals don't lose electron. Non-metals gain electron. They receive electron. I am a metal. I give. Remember the example I use. You are then this is a non-metal. Receives. Okay. So non-metal receives. So non-metal will not donate electron. Non-metal will receive. Okay. So non-metal will receive. By receiving electron, it will become stable. Receive karega and it will become stable. So it will receive electron, okay, and then become stable. I hope you are following. Okay, whereas metal loses this electron, will lose electron, any number of electron, okay, which are present in the outermost shell. They will lose it and then they will become stable. I hope you followed. And non-metal on the other hand will gain electron and they will become stable. Let me show you their stable state. So sodium will lose electron, and then after losing electron, what will be the new design for, what will be the new EC for sodium? The new EC for sodium will be the new electronic configuration. Okay, EC means electronic configuration, class electronic configuration. Okay, EC stands for electronic configuration. I will not write it. Okay, so the new EC for sodium will be, it will be like this, 2,8. Where did 1 go? Donated, lost. Okay, lost. Okay, now look at this sodium. This sodium is stable. How do I know it's stable? Because now it is carrying only 2 shells. Okay, so in order to declare whether an atom or an element is stable or not, always look at the outermost shell. Now this is the outermost shell. Look at the number of electrons in the outermost shell, 8. This is the second shell. The outermost shell now is the second shell. Previously the outermost shell was the third shell, but now after losing this 1 electron, the outermost shell is gone. So this is the new outermost shell. Look at the number of electrons in the outermost shell, 8. This is the second shell. Look at the stable number. Look at the number of electrons that the second shell should have to become stable, 8. 8 or not? Same or not? Yes. So that means sodium is stable. Alright. Then what about here? Here, what will happen? Well, chlorine will receive. So chlorine will receive the 1 electron which sodium has just disposed of, which sodium has just donated. So chlorine is the right candidate to receive from sodium, because chlorine needs only 1 electron to become 8. 7 plus 1 is 8, isn't it? So 7 electrons already with chlorine, just needs 1. So if he receives the 1 electron which sodium is donating, chlorine will become stable. So sodium is the right candidate. Sodium, okay, is one element which can form a compound with sodium. Chlorine is one compound which can form a compound with, which can form a bond with sodium. So this compound this compound is existing. Okay, so 7 will receive 1 electron which sodium has donated. So after receiving that 1 electron, okay, it will become stable. So the new EC for sodium will chlorine will be, sorry, why do I keep on saying sodium? New EC, okay, for chlorine is, it will be Cl, it will be 2,8,8. Now see, 2,8,8. Previously it was 2,8,7. Now it is 2,8,8. Okay, this is the first shell. Okay, this is the second shell, and finally this is the third shell. Okay, third shell, always look at the outermost shell. The third shell is now the outermost shell. All eyes on the outermost shell. Third shell, 8. Third shell, okay, it will settle for 8. 18 is too far away, so nearest it will be 8. Okay, so it will settle for 8. Okay, so this is now stable. Okay, so that's how metals, okay, that's how metals become stable by donating electrons, and that's how non-metals become stable by receiving electron. I hope this part is clear. Okay, now one more thing. Now see, sodium, if I ask you, okay, sodium atomic number is 11. Sodium atomic number is 11. Okay, if I ask you this question, class, how many electrons does sodium have? What is your answer? How many electrons does sodium have? What is the answer? 11 electrons. So sodium has 11 electrons. So sodium has 11 electrons. Electrons equal to 11. Okay, so it has got 11 electrons. Then if I ask you, how many protons does sodium have? What is your answer? How many protons does sodium have? How many protons? Protons are positive charge carriers, okay, whereas electrons are negative charge carriers. So how many protons does sodium have? What is your answer? The answer is 11. Okay, so sodium has 11 proton and 11 neutron. Remember, class, the number of proton and the number of neutron, the number of proton and the number of electron is always same. Okay, so you just need to know their atomic number. And if there are any one of my student, if there is any one of you, okay, who doesn't know the atomic number of the elements, I will request you to study, okay, to learn it, because it is very helpful. It will be very helpful. And without knowing the atomic number, how will you do this lesson? Okay, so it is my sincere appeal to all my students who are watching this video. If by now, if you're not thorough with the atomic numbers of the first 20 elements, actually the first 20 elements I will recommend for class 9 students. For class 10 students, I recommend the first 40 elements. Okay, that's what I let my students study in the classroom. Okay, at school. Okay, so for class 10, it should be till the first 40 elements. So at least, okay, at least the base level, first 20 elements, you should all know that, okay, by heart now though. Now, so if you know the atomic number, you come to know the proton number, you will also know the number of electrons, because they are same. Okay, so now see. So this is the original, this is the original sodium. Okay, this is how sodium was born. All right, so this is how sodium was born. That means we are talking about this one. This is the original. Okay, this is him only. Okay, this is the sodium, how it was born. But we came to know that sodium is not happy with the way, okay, with the way the arrangement was done. Okay, so what he does, okay, because he was unstable, okay, carrying one electron in the outermost shell made him unstable, so he decided that he will restructure himself. How will he do that? By losing electron. So now what happened? Let us look at the new. So this is the new sodium. So new sodium, what does the new sodium do? What does the new sodium do? The new sodium loses one electron. So if I ask you, well, remember, okay, now I ask you, so proton number and electron number, I will ask you again, what is the electron number? Now remember, sodium loses one electron, so one less, okay, one less from here, 11. So 11 becomes how much? How much will it become? 10. Okay, 11 becomes 10. So one electron lost to na, loses electron though. So sodium will lose this one electron. Okay, only the lost is one electron. So this is gone. This is no more. This is gone. So from 11 it becomes 10. Okay, like I told you, this is the original one. Okay, whereas this is the modified sodium. Okay, this is the sodium which has lost electron. So one electron lost. What about the number of proton? Did he lose proton? No. So proton number is still same. So still 11 plus. Okay, this is 10 minus. Alright, so see, if I ask you now, is the number of negative charge more or the number of positive charge more? What is your answer? Your answer is the number of positive charge is more, isn't it? Okay, so what happened? Okay, now here sodium has more positive charge than negative charge. Sodium has more positive charge, sodium has more proton than electron. Okay, so this becomes a sodium ion now. Sodium ion. Okay, this is a sodium ion. This is a sodium ion. All right, this is a sodium ion. Okay, because now it is carrying one extra more charge. 11 positive charge, 10 negative charge. So one extra positive charge is not. So that makes him an ion. Okay, so this is a sodium ion. So normal sodium loses electron, okay, and becomes sodium ion. All right, this is called cation. Okay, this is called cation. This is called cation. Cation. Okay, I'll come back to this. Now let's go to chlorine. Okay, chlorine. So chlorine, this is chlorine. This is the original chlorine. Okay, now the same thing. Okay, if I draw this, then it will be 17. So proton, how much? How many proton? 17. How many electron? 17. Yes or no? Now the original chlorine. This is how this is how it will be written. It has got atomic number 17. So 17 proton, 17 electron. But chlorine is a non-metal. Chlorine gains electron. It gains electron. So it will gain one more electron. So the new chlorine will be Cl, and then the number of proton is still same. Proton is still 17, but then electron number will be, because it receives 1 from sodium, isn't it? It receives 1 electron, so now the number has shot to 18 minus. This is plus. So now I ask you again, my dear students, positive charge more or negative charge more? It is very clear, negative charge is more. Okay, so only for only 17 positive charge and 18 negative charge, so negative is more. Okay, so one extra negative is not. So now let me remove this one. This becomes Cl minus. Okay, Cl minus. This is chlorine ion. Okay, this is chlorine ion. Okay, sodium ion. Okay, chlorine ion. When they start, okay, see, metals. Okay, normal metal, this is normal chlorine. Non-metal chlorine is a non-metal. Okay, so this is chlorine, this is the elemental chlorine, and this is the ionic chlorine. Once again, okay, normal chlorine. Okay, normal chlorine, the way it was, the way God made it. Okay, 287, normal chlorine having atomic number 17. This is, okay, normal chlorine. But what is ionic chlorine? Ionic chlorine is the chlorine which has received an ion, which has received, sorry, not an ion, sorry, which has received electron. Okay, so when they receive electron, the number of negative charge becomes more, so now it carries negative charge, so it changes to a ion. So this is chlorine ion. Remember, chlorine ion is not chlorine. Okay, normal chlorine, it's not normal chlorine, sorry, chlorine ion is not normal chlorine. In the same way, normal sodium. Okay, normal sodium, this is sodium ion, not same. This is normal sodium. Okay, the metal sodium, which has got atomic number 11. Okay, which is unstable. Got it? But this is sodium ion. This is the sodium, okay, who has lost 1 electron. Okay, this is the stable sodium. Understood? This is the stable chlorine. Gain 1 electron, becomes stable. Okay, minus indicates the electron, okay, which he has gained. Plus indicates the electron which he has lost. By losing electron, what happened? The negative charge became less, so becomes slightly positive. By gaining 1 more electron, the number of negative charge became more, so positive charge became less, so became more negative. Understood or not? Okay, so this is cation. I wrote cation. Okay, so sodium ion, okay, carrying positive charge. So since it carries positive charge, we call it as cation. And what do we call this? What do we call this? This chlorine ion carries negative charge. So what is the name for ions which carry negative charge? The name is called anion. Okay, so this is called anion. Anion. Okay, now let me speak more about anion and cation. Okay, cation and anion. Okay, anion. So how to remember which is a cation and which is an anion? So I have already told you that the positive ion, the positive ion, okay, is called cation, and the negative ion, is called anion. But then you will forget in exam. Okay, so how to remember? Is there a way by which a student can remember without forgetting? Okay, besides memorizing. Okay, so there's a small trick here. Remember, positive ion, so positive. Okay, negative ion, so negative. Okay, so the trick is to help you from the cation. Okay, so positive, so plus, isn't it? This is plus. Just make the plus longer and you get something like T, and that's it, cation. As simple as that. So now you know what is a, now there is no way you will forget cation. Cation is plus. This looks like plus. It's just an extension of plus only, isn't it? Plus ko extend karo, it will come out to be T. That's it. Okay, then anion though automatically. How easy is that? Okay, so this is how we study. Okay, easy. So remember, cation is the positive ion. So in our example, sodium becomes the cation, and in our example, chlorine becomes the anion. Negative charge, carrying negative charge, so negative ion, anion. Okay. Now, so yes, between. So what is the spelling of between? Between. Okay, between metal and a non-metal, a force exists. A force exists. Okay, this is a statement, very important statement. Between a metal and a non-metal, a force exists. So M and non-metal. So non-metal. Between a metal and a non-metal. Okay, between a metal and a non-metal. Let me just decorate it. Okay, so between a metal and a non-metal, a force exists. A force exists. Okay, so metal is here and non-metal is here. So let me just erase this one and just write N here. So this is minus now. So between a metal and a non-metal, a force exists. So there's a force here, okay, which exists between a metal and a non-metal. What type of force is this? It's an attractive force, you know? It's an attractive force. So it's an attractive force. These two attract each other. Okay, positive and negative. What type of force do you think will exist between the positive and a negative? It will be a attractive force. So the force is an attractive force. Okay, so between a metal and a non-metal, a force exists. The name of the force is electrostatic force. Very important. Okay, let me underline this. Yes, electrostatic force. Very, very important. Okay, so important for you to remember. Okay, the name of the force which exists between a metal and a non-metal is electrostatic force. Okay, so very important. Yes, so this force is what we call ionic bonding. Okay, so this force also known as ionic bonding. This is what we call ionic bonding. Now, why are we calling it as ionic bonding? Pay attention to this word ion. Pay attention to this word ion. Ionic bonding. Look here. Is it not because of the ions? Is it not because of the ions? When I say ions, I'm talking about this sodium, which carries a positive charge, and I'm talking about this chlorine, which is a negative charge. So between sodium and chlorine, they exist as a compound. How are they able to exist as a compound? It's because there's a force between them. There's a force of attraction between them. There is something which is bonding them together. Okay, so what is bonding them together? Their charges are bonding them together. One is a positive charge carrier, the other is a negative charge carrier. So their charges, positive and negative, which creates a force of attraction. The attraction is between oppositely charged particles. Yes, the word is oppositely charged particles. That is the word I was forgetting. Opposite, O-P-P-O-S-I-T, oppositely charged particles. Yes, this is the word. Very important word which I was forgetting. So oppositely charged particles. So these are two oppositely charged particles, and between two oppositely charged particles, class, what type of bonding, what type of force exists between two oppositely charged particles? Between two opposite charged particles, okay, electrostatic force exists between two opposite charged particles. Okay, so remember, between two opposite charged particles, electrostatic force exists between them. The electrostatic force is also known by the name ionic bonding. Okay, okay, very important, very important. And yes, so now coming to the conclusion, so the conclusion is the compounds the compounds form the compounds form uh, the compounds formed by ionic bonding. It's making so much squeaking noise, sorry. Ionic bonding are, let me use this. The compounds formed by ionic bonding are called what? Are called ionic compounds. Our topic, okay, are called ionic compounds. Alright, so very important. The compounds formed by ionic bonding are called ionic compounds. Okay, so class, I'll end the class from here. But before I go, I have a question for you. So let me erase this one. Okay, and then I want you all to participate. Okay, please comment the answer in the comment box. What is happening to my lights? Okay, so what is the question? Okay, so question. Okay, element X, okay, Y and Z. So the electronic configuration of element X is 2, 8, 7. Y is 2, 8, 2, and Z is 2, 8. Okay, so identify X, that means element X, element Y, and element Z. Okay, you need to tell me the names of element X, element Y, and element Z. So their electronic configurations are given to you. So looking at the electronic configuration, try to identify the element X. Okay, give me the name of element X. Identify the element Y by looking at the electronic configuration, and finally identify element Z. Okay, by looking at the EC, and the answer you give it in the comment box. You comment the answer, okay, in the comment box. Okay, so thank you all, my dear students, for tuning in, and I'll see you again in the next video.